Hello, kids, and welcome to another episode of Bright Ideas with Willy and Eddy. I'm Willy.
And I'm Eddy.
Today, we've got a very special mathematical episode based on trigonometry.
We are going to be talking about identity.
Oh, identities! Identities are the written form of equation that is used in order to transform a wave onto itself or onto others. Here. Roll film.
A waveform is a representation of how alternating current varies with time. The most familiar AC waveform is the sine wave, which derives its name from the fact that the current or voltage varies with the sign of the elapsed time. Other common AC waveforms are the square wave, the ramp, the sawtooth, and the triangular wave. The sine wave is unique in that it represents energy entirely concentrated at a single frequency. An ideal, unmodulated wireless signal has a sine waveform with a frequency usually measured in megahertz or gigahertz. A cosine wave is a signal waveform with a shape identical to that of a sine wave, except each point on the cosine wave occurs exactly 1/4 cycle earlier than the corresponding point on the sine wave. A cosine wave and its corresponding sine wave have the same frequency, but the cosine wave leads the sine wave by 90 degrees of phase.
What a fine film.
Could you explain what you meant by an equation for a wave turned onto itself or others?
Yes, I can, Eddy. There's my sine wave. Eddy, let's say I want to horizontally translate it 360 degrees positive. Matches right back up, kids. It's the same thing, negative, too.
Oh my god!
Another way we could put the sine wave onto itself is by doing a vertical stretch, which in this case will be a rotation. Do that times 1. And horizontally translate it 180 degrees. Positive or negative again.
That is very cool.
You could reflect the sine wave, which would be a horizontal stretch to -1. And then, what you'd have to do is horizontally translate it again, 360 to negative 360.
What about the cosides?
Eddy.
Wait,
Cosides
are the cosides.
Eddy, stop! Cosine waves, it's the same thing, but same thing works, because it's just the same wave, except moved back and forth.
What if you wanted to match up a sine wave with a cosine wave?
Well, degrees. If I was to put a sine to a cosine wave, the degrees would have to be a little bit different, because this time it's been moved back and forth. So it's going to have to do with 90s and 270s. Like here. Let's horizontally translate this sine wave -90 degrees. It matches up with the cosine. Let's say, let's do a vertical stretch to -1, a horizontal stretch to -1, and a horizontal translation to -90. Check that out. Matches up, right? You want to learn about the identities now? How to write the equations?
I want to know. I want to learn.
How about you, kids? Okay.
What about identities? How do you write down the transformations?
Here's a written example of what I did for the first transformation. Horizontal translation plus 360 degrees. in the world of mathematics, you have to put the inverse into the parentheses. Let's do another example. Let's say my reflection in the x-axis and the transformation plus 180. It was the vertical stretch of -1 plus the horizontal translation of 180. Here, the sign has been put into a negative, and yet again, we see the inverse inside the horizontal translation area. Let's do one more, but use rotation. This one's gonna be a tough one. I'm going to horizontally stretch it -1, which means I've rotated it completely. I will have a vertical stretch of -1, which means it will be reflected. And a horizontal translation of -180, which means it will be moved back 180 degrees. The equation, yet again, has a -1 sign for the reflection, but I must times now the horizontal translation area for the horizontal stretch to its value, which is -1. -1 will be put into the equation, which is, of course, inverted. And there you have it. Well, kids, we're running out of time. I guess I don't really have much more to explain then, unless you guys want to do some research on your own. Feel free to ask questions if you need to. And thank you, as always, Willy
and Eddie.
Would like to thank you for watching. Lights out.